Hey, Mr. P helps with Precal, Unit 4, Lesson 1, Topic 1, Lesson number 2. We're going to be talking about vector addition and scalar multiplication in this video, and also talk about all the basics that we had talked about in the last video, so a lot of summarizing what was in the last video as well. Starting off with write each into vector into component form. So remember, that's just x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Always be careful about the direction that this is going. This is the initial point, and it's going towards S, which means that's the first point and that's the second point. So always do 2 minus 1. So be careful. I know I said that in the last video as well. So that becomes 8 minus negative 3. 8 minus negative 3 is 11, and negative 1 minus 9 more makes negative 10. Over here, we have the exact same thing. So P going to Q, that's the initial point. So it is in the correct order in this case. So that's going to be, PQ, equals, negative 9 minus negative 10 makes negative 9 plus 10, which is 1. And negative 10 minus 5 more makes negative 15. There's your component form of both pretty quickly. Once again, I want to summarize everything that was in that last video, which is on this slide. First, finding component form. That's a lot like the warm-up that we just did. So component form of A, B. Now, keep in mind that we would need to know which one of these is the initial point, which isn't really told to us here. But negative 1 minus 3 more makes negative 4, and negative 8 minus negative 5 is negative 8 plus 5, which happens to be negative 3. All right, so over here we have a magnitude, and we also have a direction. So therefore, we're going to multiply magnitude times cosine of 230, comma, magnitude times sine of 230. And of course, I'm going to need my calculator. I should have had it out and ready. Let's see, that becomes 6 times cosine of 230, negative 3.86, negative 3.86, comma, 6 times sine of 230, which is negative 4.59. Now, that makes sense because that coordinate would be in the third quadrant, so I'm going to accept that as the right answer. So find the magnitude when you're given this. So magnitude, remember, magnitude is found by using that formula of negative 4 squared plus 8 squared. So that becomes 16 plus 64. So this has the magnitude of square root of 80. Square root of 80 is our magnitude. From the points, okay, so what if we're given points? So same thing, well, you're going to use that distance formula. So that's going to be negative 2 minus negative 5 squared plus 6 minus 2 squared. So that becomes negative 2 minus negative 5 is 3. So that becomes 3 squared plus 4 squared, which is 9 plus 16, which is 25, magnitude of 5. All right, find the direction of 5, negative 12. 5, negative 12, that'd be 5 this way, negative 12 this way. So finding the direction means I'm going to try to find this angle. Now, I'm given opposite and adjacent, so it'd make the most sense just to use tangent. So inverse tangent of y over x. Sorry, no equal sign. Inverse tangent of y over x. Because what I'm really doing is tangent of y over x and then doing inverse tangent on both sides. So inverse tangent of negative 12 divided by 5. And that's going to give me negative 67 degrees. So if this is negative 67 degrees, now I have to add 180 to that. So if this is negative 67 degrees, then I want to know what this angle is right here. So I'm going to do 360 minus 67.38. That's going to give me 292.62 degrees, roughly, from here to here. And keep in mind that's plus and negative, which means it's going to be in the fourth quadrant, so that makes sense. So magnitude, so that's going to be square root of 5 squared plus negative 12 squared, which equals square root of 25 plus 144, which equals the square root of 399. Looks to be what I got. No, sorry, I must add that up wrong. 4 plus 2 is 6. Sorry, 169, which is 13. Okay. Draw a diagram to illustrate the components. So we're given a magnitude of 25 and we're given an angle of 195. Well, 195 we know is going to be in the third quadrant because it's a little bit more than 180 degrees. And you know it's going to have a magnitude of 25. So that's really all we're doing there. Find the component form when given the magnitude and direction. Okay, so find the component form when given either the magnitude and direction. Okay, so if I'm just finding magnitude of these 2 points, finding the component form of these 2 points, then I would just subtract. So -8 minus 2 more makes -10, and 4 minus 7 makes -3. So there's your component form. If I'm going to find the magnitude, so that's going to be -10 squared plus -3 squared. So that's going to be square root of 100 plus 9. So square root of 109 is the magnitude. So mn with these 2 lines. And then the direction. Okay, so that would be inverse tangent of -3 y over x. Nearly did it backwards. Inverse tangent of y over x. All right, so inverse tangent of -3 divided by -10, and that's going to give me 16.7 degrees. Now, keeping in mind that negative is always going to be in the third quadrant, so I know it's not really 16.7, so I've really got to add 180 to that because those two, remember, tangent is positive in both the first and the third quadrants. So if I add 180 to that, it's still going to be a positive number, so that's going to be the real answer, which is 196.7 degrees. Okay, I'm given the magnitude and I'm given the direction, so I assume I'm just supposed to find the component form, or maybe I wasn't supposed to find everything here, but that doesn't matter. It's good practice. So this is 8 times cosine of 320, comma 8 times sine of 320. So it's just a matter of calculator work. 8 times cosine of 320 gives me 6.128 if I'm going to 3 decimal places. And then 8 times sine of 320. And that gives me -5.14. -5.142 component form. Okay, so does this make sense would be my last thing. So it's going to the right and down, which means it's in the fourth quadrant, and 320 degrees is in the fourth quadrant. So yes, it does check out. Okay, so vector addition. So fairly easy. In this case, if you're adding 2 vectors, one way to do it is to just add them as they are. So if you have vector u and vector v, and you just add the 2 x's and add the 2 y's. Pretty easy. Or you can do that graphically, which is what I like to do, which is I'm going to start right here at 0, 0. I'm going to make vector u, which goes to here, and I'm going to do from here. So this is called heads to tails method or tail to head method, because I'm going to start this one not at the origin, but I'm going to start it at the end or the tail of the first vector. So 1, 2, 3, 1, and that would look like this. Now, the sum of those 2 vectors is going to be this. So from that beginning to that end, which would be right 5 up 5. So it looks like 5 is the resulting vector. Now, I could have just said 2 plus 3 is 5 and 4 plus 1 is 5. It gets you the exact same thing. But we have multiple strategies for multiple scenarios that you would need. So if I'm going to do a plus b, well, the first thing I'm going to do is I'm going to find all the vectors of all of these. So this is 1, 2, 3, 1. And vector b happens to be 1, 2. And c happens to be -2, -1, 2, 3. And do keep in mind which direction the arrows are going. That does matter. 1, 2, 3, 4, 5. 5, -1. Okay, so now I've got all the vectors. So if I'm going to do a plus b, so I'm going to do it graphically and by adding. So a plus b, that would be this plus this. So that's going to go right 3 up 1. So there's graph A, and then graph B is going to go right 1 up 2 more. So there's A, there's B, and the resulting vector would be this. And the resulting vector is going to end up being 4, 3 because I'm going right 4 and up 3 is the resulting vector. If I'm going to do 2A's, so that's 2. So if I start here, that's 2 right 3 up 1s, right 3 up 1. So there's your A, there's another A, and then C is going to go left 2, down 1, 2, 3, and then the resulting vector is this, which is right 1, 2, 3, 4, down 1. So right 4, down 1 is the resulting vector. Now, you could do the exact same thing and just multiply vector A by 2, and that gives you 6, 2, and then add that to vector C, which is -2, -3. I know I ran out of space. 6 plus -2 is 4, and 2 plus -3 is -1. You're going to end up getting the exact same thing. In 11 minutes, I'm doing all right on time. So A minus B, I'll do a couple more. So A minus B. So if I am subtracting, so I'm going right 3 up 1, but then I want to take away B. So instead of going this direction, I'm going to do the exact opposite, which is go the opposite direction, which is going to be left 1, down 2, left 1, down 2. And there's A taking away B, and my resulting vector ends up being 2, -1. Same thing, so if I do A, which is 3, 1, and I take away B, which is 1, 2, 3 minus 1 is 2, so it gets the same answer there. And 1 minus 2 makes -1. Same answer there. Do one more subtraction. I'm going to skip the additions because I've kind of already covered those. C minus 2A. So I'm going to start with C, which is -2, -1, 2, 3. So that's this vector. And then minus 2A. So I'm going to do the opposite of 2A. So I'm going to go left 3, down 1. So left 1, 2, 3, down 1. Left 1, 2, 3, down 1. So there's -A. There's another -A. And it looks like we're going a long ways for a resulting vector. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. -8, -5, I believe is our resulting vector. Unless I kind of messed up and going too quickly. So let's see. -2, -3 was C, and then minus 2 times A, which was 3, 1. Okay, well, 2 times 3 is 6, so this really becomes 6, 2 when you do the resulting vector there. So -2 minus 6 more makes -8, check, and -3 minus -2 makes -5, check. This was the correct response. All right, 2 minutes left to cover scalar multiplication. So it's really no different than what we had just done. So doubling U. So if this is U, vector U, and this is vector V, so double U is going to be just 2 resulting. And -1 V's means instead of going to the right, it's going to go to the left. So the red is the resulting vector of -V. 3 V's will just be going to the right 3 times that same magnitude. So V is the magnitude. So you're going that direction. And this will be 3 U's minus V's. And the resulting vector is the red one. That's your answer right there. Notice that what I didn't go over this. K times U is just, that's your scalar. That's what you're multiplying by. So if you're multiplying something by a vector, all you have to do is multiply, it's just like distributive property. So you're multiplying K times the first number and the second number, as you can clearly see in the directions. And what if you're given the magnitude? Okay, this is really just a review of what we had done earlier in this video, and I know I only have a minute left. What if you're given this? So that would just be magnitude times cosine of 126.87, and then comma magnitude times sine of 126.87. And then it's just a matter of putting that in your calculator and pressing enter. I am going to stop right there. I'm down to 30 seconds left. I've been pretty much using all my time in these videos. The next couple, I think, are not as long. Thanks again for watching, and please give it a like if I helped you learn something about vectors. Thanks again for watching.